Welcome, everybody. So glad to see you and so happy we are all together again today. I would love to introduce Glenn Grossman, our host. He is an epidemiologist with over 20 years of experience. While pursuing his doctorate in epidemiology at UNC Chapel Hill, Glenn served as an epidemiologist on staff at the UNC Infectious Disease Clinic for 2 years and taught epidemiology and advanced analytics at Duke Medical School and at UNC. He has been involved in epidemiology projects with Medicare, Medicaid, Veterans Health Administration, Military Health Service, the CDC, and other programs in the United States and abroad. He is currently Senior Director of Outcomes Research and Epidemiology at Novartis, but all views expressed today are his own. So, Glenn, we'll stick with our tradition. Normally, we start off where you give us an update since we were last together on how things are going here in the US and globally.
Hey, Becky. Yeah, for sure. Just give me 1 second to share my screen. All right, that should do it. Okay, so we have another week where we've gone way down in new cases, which is great news. So here we are. We had under 400,000 new diagnosed US cases over the last 7 days. The week before there were 437, and the week before that there were 465,000. So we're going way down. However, our best estimate of the number of actual new infected patients, or they're not patients because they're not being treated or diagnosed, the number of new infected individuals is closer to 388,000 per day. And so that means that we've diagnosed less in 1 week than our best estimate of the number of new people infected in a single day at this point. My best guess is that we're getting worse and worse at diagnosing patients, which is unfortunate. I think that there really is a signal that the numbers have decreased some over the last few weeks, but at the same time, hopefully we'll get into this discussion a little bit later. I think that the diagnostic testing is really atrocious and getting worse. So that's something for us to discuss. Give me 1 second to pause share. All right. And let me do. All right, so first I'll show you this. Oops. I want to go to this. All right, so what you see on my screen is the number of daily tests have been going down a lot since around July 29th. Actually, so this is at the national level. When we'll look at the state level, if we get into that a little bit later in terms of the diagnostics and in terms of our diagnostic stuff, you'll see that in terms of actually where the cases are occurring, it was actually happening closer to July 17th was the height of where the total tests were in a lot of these states. So Florida, Texas, we'll get into that. So these numbers going down, you'll see earlier, Trump was saying for a while that the reason that the cases were going up was because the testing was going up. But you can just see at a glance that that's not the case. What you see is that testing was increasing, but when cases truly were going down, you saw a reduction in cases. We were just getting better at diagnosing them and finding the patients. But now what's happening is with the testing going down, we're getting worse at finding the patients. Additionally, one thing that Trump likes to look at is the number of new diagnosed COVID-19 cases per million. So this is the most recent day. Right now, Peru has had the most, Brazil, and to remind you, so right now it's winter in the Southern Hemisphere. So this will be what our winter looks like, probably for a variety of reasons. One, we know that our reproductive value increases a lot in colder weather. Two, it coincides with flu and cold season. So that means that the symptoms for spreading it are no longer just coughing. If people have flu and colds at the same time, and they're sneezing everywhere, then that makes the virus spread much, much further and faster and easier. And so there's a lot of things, people spend more time indoors during the winter time. There's a lot of things that happen that just increase the R value and makes the spread much, much more likely. And then among people who get it, it seems like there might be increased risk of morbidity and mortality, although we're not clear about that right now. When we look at the most recent, United States is doing quite poorly. When you look at other things, other metrics, so for instance, Trump had this crazy interview in the last week that some of you might have seen, where he was saying, oh, compared to these other states, we're not doing so poorly. But virtually all metrics were doing quite bad. And the reality is, this is at a federal level. This is at the national, at the state level, at the national level for the United States. When you dig into this and actually look at the state level, then so here you see Peru was 211, 212 new diagnosed cases per million people. But when you look for us at the state level, here's Florida at 290, here's Alabama at 601, Louisiana 571. So you see that at the state level, we're actually doing quite a bit worse in many states than in others. And so the national level, we really, our country is so big, we really need to look at this as lots of different outbreaks instead of one outbreak, just because they all have their own curves and they all have their own unique circumstances associated with that. And when you aggregate it to the national level, we sometimes hide some of those dynamics that are going on, so it makes it harder to interpret. Let's look real quickly at some of the other countries that are beating it. So, oh, and I can come back here for a second. So this is, whoops. All right, so right now, the key things I wanted to show you were that, whoops. So right now, South America, the Southern Hemisphere is doing really poorly, but it's winter time there. So it's a little bit hard to compare because of that. So I'm gonna unselect some of these just so we can see the comparison. And now with the exception of Sweden, you can see that the United States, in fact, let me remove Sweden for a second. So now you can see when we compare Europe to US, Spain is a little bit of an exception. Spain is over the last few weeks has started to get a little bit worse, nowhere near at the levels that the United States is. But you can see that we have a lot more diagnosed cases. And again, our diagnosing is abysmal here. And so we're missing the vast majority of new infections. And so when we look at this in terms of other countries, there's a lot of countries. A lot of these are smaller, but a lot of countries are doing quite well right now, relative. I don't like the way that some of these are shown because it doesn't normalize it. The height of the curve of Monaco, where there were only 128 cases total during the whole epidemic, looks like it's the same height as something like Malaysia, which had 9,000. So over an order of magnitude more, almost 2 orders of magnitude more. And so, yeah, so I don't like the way this is showing, but it's still at the same time, at a glance, it's really interesting to look at. So for instance, a country like, let's see, so in yellow, you can see Europe. At first it was doing poorly, but a country like Germany, which is pretty large, they had 216,000 total cases. In the last day, it was 828. So it is going a little bit. They do need to keep an eye on this, but they're doing much, much better. You see their curve compared to what the United States is. We are here. It's totally different curves. And so what this means is that we know, I was having a conversation earlier today, and they said, well, on paper, the advice of the epidemiologist makes sense, but in the real world, we can't shut down things because in the real world, it would just be devastating at this point to the US economy. And so I said, well, no, on paper, this is not about paper. This is actually real world evidence that the countries that have succeeded, we know exactly what they did. They had huge shutdowns until the number of new cases were so low that they were able to reopen. And then when the numbers were low, they can do testing and contact tracing and keep the numbers low for a much longer period of time. Whereas us, because we never got low, we had no logistical capacity to do the testing and contact, and particularly the contact tracing that we needed to do to get the numbers near zero. Anyway, at a high level, this is where we're at. Let's start getting into questions, Beck. Okay.
Yeah, well, go ahead.
I was just going to say Sweden comes up a lot. I talked about Sweden a little bit last week. They are rising a little bit versus where they were last week. They're not looking like much of Europe, but frankly, when you look at Spain and you look at some of these other countries, they fought really hard at first too. They did get it somewhat low, but now their numbers are starting to rise again as well. Although at this point, I do think that they're doing a much better job of testing there now. So remember, these are all diagnosed cases. And so I think because they're doing a much better diagnosing now, then their curves are actually not apples to apples. So the diagnosed cases here were a much smaller percentage of the diagnosed cases here. So it's not really apples to apples.
What's happening in Italy? Remember how it was always, we don't want to be the next Italy. Where is Italy now?
So Italy is doing great. They had a big curve at the beginning. They brought it down because they were just really wanted to make sure that they could get it under control. With the lockdown that they had for, I think, roughly 2 months or so, they were able to really keep it into manageable levels. So they have, approximately 300 new cases a day. And that's a little bit higher than they were having. But at those numbers, you can easily keep that under control with contact tracing and testing, and especially during the summer when it's people are outdoors and with mask wearing and stuff like that. So Italy has gotten it under control for the time being. It's still a little bit burning. It's not completely gone. There's some countries that were successful. I think New Zealand's a good example. Let me see if I can pull them up, where they had one case in the most recent day, and it's that New Zealand has been doing exceptionally well at keeping it down. They were much closer to China than a lot of other countries, and they had visitors, and they just shut the country down. And as a result, their economy is great. People can go and do whatever they want. There's so few cases, they really don't have to worry about it there. So the experience, my point here is that the experience that we have in the United States, where do we reopen the schools and how do we deal with these things because it's spreading so much, and with the hospitalization and everything, a lot of other countries are simply not asking those questions right now. They dealt with it. They got it down to numbers that they can deal with, 44 new cases a day here, and so for them, their economy is opening up more, and they can do things, and it's not an issue for them. They've closed their borders to us. The American passport, the American visa is no longer good in a lot of these countries during this pandemic because of our poor policy choices. But
shocking, and also frightening to see what's happening in the Southern Hemisphere. But I do have to say, I did take away one piece of interesting information from your presentation just now, and that is the next time I play Pictionary, I want you on my team, because the way you showed the sneezing was quite descriptive. So let's keep our sneezes like that, right?
Sounds good.
But, so you talk about adding flu to the mix, but by now, a lot of people, not everyone, a lot of people are wearing masks. So, won't that help the sneezing that you showed us?
So yeah, people are wearing masks a lot more than they were. This is a big question. We have less flu this year than we would have otherwise because of the people social distancing and wearing the masks and the other things. And in the South, in the Southern Hemisphere, we're not seeing that yet. We are still seeing spread of flu and these other things. The problem is that flu, it's the same kind of thing that we are not doing now. So people are wearing masks and have gotten better at the respiratory component, but I think that we're still not doing quite as good a job at hand washing and things like that as we should be doing. And so touching the same doorknobs and touching things, someone could have been, I don't know exactly how long the flu lasts. I should know this in terms of on the surface, but at least multiple minutes. So someone could be in the room that prior to you. If you go into a room after them, it seems totally empty. You could just rest your hand on a desk or a table or something and then catch the flu there. And the mask doesn't prevent you, once it's on your hand, from scratching your face or your arm and then infecting yourself later. And so it's even though flu is also a respiratory illness, there is spread that's going to continue through touching and through other things. When a lot of people are still not wearing masks. They might wear them outside, but as we switch to being more indoors, as the weather gets cooler, it's going to be a much bigger challenge for us over here.
Something that I've recently sort of gotten better at, I wonder if everyone else has too, is sort of wearing the mask once and then putting it in a dirty bin and washing everybody in the family's masks and not wearing masks more than once. I used to hang it on my rearview mirror and think the sun would disinfect it and put it back on. And I don't do that anymore. So I know you're proud of me.
Well, the sun, we talked about this a couple months ago. I can't believe that it's been so long. It seems like, at least now, at first it seemed like it was going on forever. And now it's like a couple months have gone by. So I guess that's realistic. So we did talk that there have been a bunch of studies looking at UV light and looking at exposure to sun. The problem with the mask, though, is that it prevents, like the upper side would be exposed to the sunlight, but the lower side might not be exposed. So just the air alone might be good at disinfecting it if you don't wear it for a couple of days. But yeah.
Awesome. All right. So again, reminder to everybody, if you have questions, send them in. You can send them to me via the chat and I'll get them in the queue. I know people have been sending in questions during the week, so thank you for that. So I will take us through some of those questions. So a question that came in is, we talk a lot about mortality. What about morbidity? Do we know anything more about persistent symptoms or disease in people who were infected?
So yes, we do. So let me talk about this a little bit more. If I can find some slides. All right, so there's a long list of lingering symptoms now that we're finding in more and more people. And so some people seem to get better and then they have symptoms that might return a little bit. We're still trying to figure it out. There's more studies that have been launched to try to evaluate this. This was a recent article that we're looking at in Science, the journal, which indicated, I think this was a news article, so it was just a summary of what they found. But so we found that among patients who have a lot of these symptoms, headache, fatigue, insomnia, chest pain, cough, joint pain, brain fog, shortness of breath, heart arrhythmia, and hypertension, a lot of these things are continuing to persist. I mean, the fever, other things persisting. And so let me see, racing heartbeat, we talked about loss of smell, it persists in some people, and there's other abnormalities, other clinical abnormalities that are being found as well. And so right now it's just persisting. We don't know how long they're going to take to go away. Some of them are probably due to some organ damage. But I mean, just because it's organ damage doesn't mean it can't heal over time. If there's scarring in the tissue, there's fibrosis. If there's scarring, then it might take a little bit longer to heal. There might be some long-term symptoms that just don't go away for some time. And so this is, when we talk about the seriousness of the disease, at the very, very beginning, at the first weeks and months, mortality was the focus. That had to be the focus. But now symptoms are going to become at least as important going forward, because after the epidemic ends, let's say in a year or 2 years, when people are vaccinated and the drugs are out and everything, these symptoms don't just suddenly stop going away for a lot of these people. And so this is going to be something that we're going to be talking about for a long time. And so this is an issue. In fact, there's a couple other things that we're looking at. There were some really interesting studies. This was a couple of weeks ago, I think, at this point. This was July 27th. These articles were published. One study looked closely at the hearts of people who had died of coronavirus. And so we weren't sure for a while if people were dying mostly because of the cytokine storms or because the virus itself was infecting organs around the body. We know that the ACE2 receptor is located all throughout the body. So I've been assuming that the virus was infecting the body all over, that it wasn't just a lung disease with the cytokine storm, but that it was actually infection that was occurring throughout the body. And indeed, this study of people who died, they found that that 62% of patients had heart cells that were infected with the virus. So the virus was actually found in the heart, and this is a good indication that the virus truly is replicating ACE2 receptors across the body. So it's not just a cytokine storm issue, it's true infection that's systematic, that's across the body. The other study found that 78% of 100 surviving patients, so 78% of them, had some impact on the heart, and 60% had ongoing heart inflammation independent of any pre-existing heart disease. So again, these are people who survived, they went home, they were better in terms of getting out of the hospital and were able to go home. 78% of them had heart changes, that there were actual physical changes that you could see in the heart that were a longer term consequence of the disease. And not only that, in terms of the disease being over, 60% continued to have inflammation in the heart that was separate from any pre-existing disorder they might have had. So even if they had some sort of other heart disease going on, this was an inflammation that was on top of that, completely new, and was continuing. So it wasn't just that the damage was done, the damage is continuing, even among people who seem to have recovered, have negative virus tests when they get the tests, and it's all coming back negative. And that's again because even though the virus is replicating throughout the body, our virus tests, these PCR tests, the polymerase chain reaction tests, are typically only conducted in the nose or in the mouth or in the saliva. And so because of that, you only are going to pick up active replication in those areas. But if it's taking place throughout the body, the gastrointestinal tract and the cardiovascular system and the heart and other organs, then we're not doing tests for that. So there's no way for us to know if it's ongoing. And what we're finding is that, yes, indeed, it is ongoing in quite a lot of people. All right, let me see if that, oh, there's one more. And so I think I mentioned this study previously in a previous week, but I just wanted to bring it up again for this question here. And so in Italy, they interviewed a bunch of people who were hospitalized, so a bunch of patients who were hospitalized, and then they interviewed them 2 months later after they were released. And they found that only 13% were completely symptom-free of COVID-19. So there were no COVID-19 symptoms after 2 whole months. 13% were symptom-free. 32%, so roughly a third, had 1 or 2 symptoms, and 55% of all of the hospitalized patients who survived had 3 or more symptoms 2 months after. So the symptoms, these symptoms are nothing to just try to not look at. We need to be talking about the symptoms. This disease is serious. I've talked to people, some of them who might have been on this discussion tonight, and also just other people, where some people say, well, they just want to get infected and get it out of their system so that they don't have to deal with it anymore. But the reason you don't want to do that is that there are underlying disease processes. And even if you don't have symptoms, you don't feel it, there are underlying disease processes where the infections are occurring in organs, possibly throughout the body, that might have long-term consequences. These are just symptoms. These are things we can either see, or in the previous study, these were things that we could look at through magnetic resonance imaging, through MRI. But there's processes that we're just beginning to even look to see, to know what's going on. And there could be other long-term consequences in addition to the scarring, in addition to these things that have not been discovered yet. So this is not a disease. We do not want to get infected just to get it out of our systems. This is a serious illness, and we need to be aware of that.
A great point that you raised. You know, I remember at one point people were saying, well, maybe chickenpox parties, something similar to that. Well, this will evolve into that. And what you're saying is absolutely not. We want to avoid this at all costs and not get it over with. Okay. So I am going to unmute Arlene and Harry Grossman. They had a question pertaining to masks. So here goes. Just there you go. Can you click unmute?
Okay.
Different masks provide different levels of protection. And there's been some research that indicates that a variety of the masks that people are using are basically worthless. Would you go into a discussion about what makes a mask good or not good besides just the N95 or NK95?
Yeah, sure. I wouldn't say that they're worthless, but let's talk about this. All right, so Duke came out with a study in the last week or so. And some of you might be familiar that if you're near a window and the sunlight is coming through in an otherwise dark room, you might be able to see some dust that's circulating in the air. And so they had a really interesting idea. And so what they did, we know currently, and one of the motivations for them doing this was that in our current atmosphere, our current political atmosphere, a lot of people just don't trust scientists. They don't trust authorities. They don't trust experts. And so Duke, I think this was a Duke Medical School, they had a really interesting idea. And they said, well, what if we were to design an instrument so people could test the effectiveness of masks at their own house? And so through very inexpensively, all you have to do is create a cardboard box that I guess that some students doing science projects might be interested in looking at this in the coming months. Cardboard box, you cut it out, just a laser that you purchase from Amazon, just a really cheap little laser that should shine some light. You shine it through a slot in the box that you've created, and then you can put different masks on and then just talk in the masks and then in front of the box. And then you can use your iPhone, and then the iPhone, there's an app, and it can detect based on the number of particles that it sees how effective the mask is. So this is really interesting. One thing I didn't like about this experiment is that I think you have to breathe through the mask. So it's essentially only testing what your what the filter is in terms of the breath that's coming through. The problem is we know is a lot of people who wear masks don't wear them exactly the right way. And so if you wear a mask and your glasses fog up when you wear the mask, then that means that the air is just fully escaping. And so the filter is having zero benefit if you're wearing the mask and the air is just fogging up your goggles and going out the sides. Because if you were infected, then any of the virus particles could just be going out the sides, and it wouldn't be as helpful. It would be for the bigger droplets, it might make a difference, but for smaller droplets, especially aerosolized ones, it wouldn't have any protective effect. But so based on their study, but the study was really interesting. Based on their study, they looked at 14 different types of masks in terms of clothing. Let me make this bigger so you can see what they are. So number one, this was a surgical mask. This was a valved N95 mask that people have talked about. This was a homemade knitted mask. 4 was a polyprop. I won't go through all of them. Some of them might be familiar. The 2 that you might not have seen are a fleece, which is sometimes something that I wear. I usually wear 2 or 3 layers of them though. And then the bandana that sometimes people wear. And then also number 14 was the fitted N95. The fitted masks tend to be much, much better because it's easier to get a tight fit than some of these other masks that are just the rectangular ones that we've seen, where you put them on and it's just so easy for the air to go out the sides. But anyway, having said that, they compared all of these masks to not having any masks. So not having any mask was green, and then all of these were the masks that they looked at. So the fitted N95, which was this one, 14, this was by far the best. The surgical mask, which was up here, was second best. And so you see, these are the gold standards that we've been using. They fit the face well, they do well. These were the best ones, and they were way, way, way better than doing nothing at all. Then each one is just incrementally worse. Again, assuming that you have the best fit that you can with any one of these masks, you can still see that the fabric itself makes a difference in terms of how protective it is, both in terms of getting infected if you're wearing the mask, or if you're asymptomatic and don't realize you're infected, and wearing the mask and infecting others. Again, if you are sick, it's probably better to just socially isolate yourself, quarantine yourself, and then not even risk going outdoors or outside or interacting with anyone at all, because you don't want to risk infecting anyone else. And with the chains of infection, either that person or someone further down the chain of infection dying because of your decision to go out in public with a mask that you know is not 100% safe or effective, let's say. But interestingly, this was interesting, the bandana is not very effective. So compared to nothing, the bandana is not very effective. And even worse, I just said with the fleece, that I sometimes wear this, I use multiple layers. A single layer of fleece is actually worse than wearing nothing at all. And the reason is that the thinking is that with the big droplets, it might be the case that with the fabric of the fleece, it actually disrupts it and makes smaller particles come out. So instead of having lots of big particles that are prevented with the fabric, instead now you have lots of particles that come out. So this is actually bad, and most people should not be wearing fleeces. The reason I like a fleece is because I have multiple layers. I keep one layer tight and one layer loose, and then a third layer on top of that that's also loose, so that I try to direct my breath further down in a way, and then it gives it more space to get captured in the fabric instead of just going out through my mouth. But even this, for most people, we should probably not be wearing fleeces, and should probably instead be wearing the number 14 here and the number 1, the fitted N95 or the surgical mask. And that's it. And the surgical mask is the typical 3-layer mask that we've been talking about. But I like this. I don't know how many people who don't trust experts are going to trust that this design will give them an answer. But at least now there's a do it at home, do it yourself approach to testing to see what works and what doesn't work if they don't trust the experts.
That is so cool, and I would like to try that. Do you happen to know the name of the app?
I don't know the app. Here's the study.
I can look it up. I'm going to look it
All right.
up because I think
Yeah, look at
it's a fun home experiment.
Yeah. Well, and so the name of the study is the Duke Medical School mask, and it was published in the last week or so. So if you just Google it, it'll come up very quickly.
Okay, excellent. Thank you for sharing. That's really, really interesting. And that the chart was really descriptive. I don't know if anyone else was surprised to see that all of these thick cotton masks were not as effective as like just a disposable surgical mask. And
well, but the one thing to keep in mind, the one thing to keep in mind, and sorry for over talking you, is that if this is 100%, then that means that everything under here, it's reduced by 80%. So all of these masks still reduce it by 80%. The benefit is that this swath, I don't know which the swath was. Swath was number, oh, I don't know. Oh, here's swath. Oh, just a swath. It's just mask. It's propylene. Just propylene itself. Just wearing literally just a swath of propylene fabric reduces it by around, what is this, 10%? So let's say 90%, which is great. And then if you look at these other things, so this coming down to say 5%, these are reducing it. Even the polycotton is reducing it by maybe 95%. So the surgical and the fitted 95 are even better, getting it down to, I don't know what that is, maybe 99% protection, maybe a quarter of magnitude. But these, it's not like these masks are worthless. And we knew going into this in terms of recommending masks that even if they weren't perfect, an 80% reduction is still huge. And so that's why we're still recommending them. But if you are interested in getting the extra little bit of protection, then these are some options for you.
It's really excellent. Maybe we can find a way to decorate the surgical masks so they can be quite beautiful.
Well, the only worry you would have is if you somehow disrupted the fabric itself based on I don't know, whatever the chemicals are that are in the decorating tool. If they were to dissolve it or something in some way, that might not be good.
Because part of the fun of this whole mask experience is being able to tie-dye your own masks and have your own so that people are willing to wear them.
Yeah,
so
I think, and if it makes people more likely to wear a mask, then definitely do the decorations, definitely.
Decorate. Okay, Sandy Rock, I am asking you to unmute, please. Sandy has a question about mask wearing in other countries, and then additionally a question about viral shedding in children.
Okay, hi guys. First of all, I was told that if you have 2 layers of, I lost them.
No, we can see you. We can see you.
Can't see you, so that if you have 2 layers of cotton, if you put a little, if you can put some sort of slit into your mask so that you can put a layer of polypropylene inside. I haven't done that, but they say that that really is very effective. But as far as children, masks around the world, Glenn, have you been hearing anything about any other countries where epidemiologists are being threatened, or superintendents of school, I heard in Memphis, are being threatened about all these decisions and about mask wearing, and are people revolting like they are in many other, like they are here, or is it pretty stable around the world? And then I can ask my other question after.
Yeah, so just anecdotally, I mean, I don't know if there's formal studies. In the United States, it is absolutely particularly bad, where people are getting death threats. Fauci's family has been getting death threats, and his daughters apparently. It's bad here. We haven't come together as a country. Frequently, when you have big issues like this that hit a country, the country comes together and it really brings people together. This country has not experienced that at all, as far as I can tell. In some ways, it has separated us more, and it's become a political issue to separate us, whether to wear masks or not. In some other countries, they do have similar types of issues. Like, so for instance, there was a big rally in Germany that I read about in the last week or two, where they were against all the heavy burdens of having to isolate and having to not go to the restaurants and stuff as much as they were before, not being able to go to large parties and stuff. And so other countries, it's a burden. Other countries are dealing with this as well. But the United States in particular has been abysmally bad, and this is what you get.
Okay. You want me to, Becky, are you ready for my next? My other question was, a couple of weeks ago, they were talking about when they were testing children, small children who were perceived to not be very contagious, that they found a fair amount of virus in their nasopharynx. And, but they never quite said that they were infected or that they were sick, that they just had the virus. Well, doesn't that mean that they are positive, coronavirus positive, and B, that they're contagious to their teachers, to their parents, and so forth? So
Yeah,
I don't, it kind of disappeared, and school is starting, and I thought it was pretty essential, and I'll mute myself.
So yeah, it's a really interesting idea. I don't know that particular study. I think I came across it in the last week or two or something like this, but I don't know the specifics. But there's a couple concepts that we have to be aware of. So the first is that just because someone has a positive test result, that they identify the virus, the RNA in the virus, doesn't mean that it's actually infectious. And in fact, that's one of the things that we're finding in kids, is that it seems like a lot of their viral shedding might actually not be infectious. And the reason is, for instance, if there's antibodies or other things that cling on to the virus, then it might not be viable. And so the only way to know if the virus that's shedding can actually spread and get other people sick is if they take the virus, then they culture it in a petri dish, and then they try to grow it. And if it grows, then they know that it can replicate and it's viable. And if it doesn't grow, then they assume that even though the person is shedding virus, it's actually not alive. Virus isn't living. It's not viable, and so you don't have to worry about it. Actually, right now the tests are so as it is. It's so hard to massively test everyone with the cheap test that the best we can do is test to see if there's any virus at all. But we don't know if this virus is viable or not. So in a lot of people, our best guess is it's probably not viable. In fact, when you look at the other studies from what I've talked about in the last few weeks with the kids, that they do not seem to be heavy spreaders of the virus. They could spread a little bit, but that a lot of the viral spreading is actually from older people. Then it doesn't seem like even if they are infected, that it's actually, they are spreading it to other people very much, even if there might be some viral load that's identified. So it doesn't worry me as much about that issue.
That's a great question on a lot of people's minds, for sure, with schools opening around the country or on the precipice of opening, and that's actually very encouraging to hear, particularly because, and then if you add on top of that, that many of the schools are requiring that everybody, students, teachers, administrators, cafeteria workers, etc., wear masks, that's actually really encouraging to hear. So thank you for the great question, and thank you for the great response. Let's talk about, last week we spoke about eye protection, and you gave some really great information about face shields and goggles, and spoke a bit about, I asked you if the vanity glasses would be effective in addition to the masks. Is there anything, any other new information on eyes and transmission through the eyes?
Yeah, so last week I was pretty suspicious about it, just because I said that there were multiple ways of getting infected, and only one of those, so let me share my screen. Only one of those was from like a splatter shield would protect in terms of the big droplets coming. So let me share my screen here. All right. And so we talked about this. So this was an example of a face shield. And so it's like, I just called it like a splatter mask. And so they use these mostly in hospitals and maybe emergency responders, and dentists and other people who come into contact, but it's mostly to protect from big droplets of things. And so I looked at the literature. I didn't have time last week to look at the literature very much. There is a little bit of some publications that have been done that are really interesting. So I wanted to share that with you. And so to my surprise, so we've seen studies like this, figures like this before. And so the way to interpret it again is, so all these rows are different studies that were done horizontally, or so vertically rather. If you see that something is 1, then it means that there's no effect. If something is greater than 1, then it makes it worse typically, and depending on how the study is defined. But in this case, it makes it worse if it's greater than 1, and if it's less than 1, it's protective. And so the further to the left you go, the more protective it is. And surprisingly, when they looked at MERS and at SARS-CoV-1, which are both related coronaviruses to COVID-19, to SARS-CoV-2, they did find really strong protective effects of the face shields and goggles and things like that. It wasn't clear exactly what type of protection was better or how it was used. They were very vague, and the studies were quite small typically. If I had gone into the specific studies, it would probably reveal more details. But in this review study that I have referenced here, it wasn't clear in terms of how to interpret it. So I interpreted it just as eye protection in general. And so sure enough, eye protection does seem to have some benefit for particularly the large droplets. Again, I want to revisit what I said earlier, that from my perspective, the biggest things that people can do are physical distancing and being outdoors, and then face mask. And I would reverse the order. So I would say being outdoors is most important of anything, then physical distancing, then a face mask. If people can do all 3 of those things, then I still believe that the incremental additional benefit is probably pretty small. But then if you need to sacrifice some of those things, so for instance, if you're forced to be indoors and be in a classroom, well, if you can still physically distance 6 feet, then it's probably not as important. But if kids are interacting in the halls and other things, then maybe there is some importance there in terms of wearing goggles. I don't know. So this is just still an area of uncertainty. I do know that Fauci has recommended it, and that means something. And so in terms of what the interpretation of the best eye protection is, I don't know what that would be. Whether glasses, I mean, I would think that a vanity glasses where it's not a prescription lens, but it's just a transparent lens that kids can see through. I mean, maybe all the kids are not going to be wearing glasses this next year. I don't know. I just, all of the evidence that we have is that in MERS and SARS, it did seem to have an impact. So I just don't know a lot more about this. So yeah, this might be something you want to consider.
Okay, thank you for that follow-up information. Definitely really helpful. What's the latest with hydroxychloroquine? I'm not saying that right, am I?
Hydroxychloroquine.
Hydroxychloroquine. What is the latest? I feel like we've not heard a lot about it recently. It was very popular, a word that was thrown around a lot early on. Is there any news lately on that particular drug?
Yep, give me 1 second. Hydroxy. I meant to open this earlier, but I failed. So let me just find it. Here it is. All right, now I have to share my screen. All right, so first and foremost, around the time that Trump, I don't remember the original date, Trump came out and said that he thought that hydroxychloroquine was the best thing since sliced bread and would cure COVID-19, and it was great, and everyone should be taking it prophylactically. And then it became a political thing, and a lot of Trump supporters thought, oh, it was so great. It was given an emergency use authorization by the FDA. And so again, an emergency use authorization, that's sometimes called an EUA, enables prescribers or physicians to prescribe this medication, and it's considered a legitimate therapy because it's FDA. It's sort of like a temporary approval in an emergency situation. And now, and that was before we really had much evidence, but there was political pressure to do it, and it seemed like there was sufficient evidence that it could be a safe and effective drug at that point, but it was only a candidate for clinical trials. No clinical trials have come out yet. And so at that point, it was given an EUA. Then the FDA revoked the EUA on June 15th of this year. So now it's no longer approved by the federal government, by the Trump administration, to be used for anyone unless there's an ongoing clinical trial that people are still investigating its use for something. For COVID-19, obviously there were other therapeutic benefits of it. That's why it was still on the market for other things. But for COVID-19, this is not something that people should be prescribing. And because the emergency use authorization has been removed now, it's been revoked, then that means that prescribers who do prescribe it for COVID-19 might be putting themselves at risk for malpractice. And so probably should not be doing that. But because the level of evidence isn't there. And so here I can show you in more detail the type of evidence. We've looked at this pyramid before, where the lowest level of evidence is expert opinion, just what experts believe. Who cares what people believe? We need to see real world evidence. And in epidemiology, those are studies that are published and are where there's very clear, rigorously conducted methodologies, where it can be replicated, and the standard science. Expert opinion is just a person's opinion on what they think. That's the least. So even Dr. Fauci, other credible people, Dr. Stella, who came out, Donald Trump, these are all opinions of people, but they're just opinions. It's not real world evidence. Don't pay attention to opinions. The next step up are case studies, where you might look at a few people here or a few people there, and you just see if it helped those specific individuals. But that's also for a disease like this very, very weak. The next is an observational study, and this started becoming more common. You can do them much, much more rapidly. And so early on, a lot of hospitals were doing this, where you gave them to people systematically, and then you just observed to see who did well. And the problem with these are that there's typically a selection bias. And so in these cases with the observational studies, there were a bunch of early studies that came out suggesting that there was a benefit for hydroxychloroquine. And these were real studies that were published. There was evidence supporting it. There were also some other studies that came out that suggested that they were not effective, also observational studies. But observational studies you can't trust, because the only ones that really matter are the randomized controlled trials, and then above that, these meta-analyses that sort of are systematic, quantitative summaries of the existing randomized controlled trials. And so, so there's the selection bias, where you don't know, did the people who recovered, were they more likely to recover because they were the ones that were the healthiest going into it, and they were the ones given the drug. So, or vice versa, maybe there were people who were the sickest of the sick and they didn't want to risk experimenting on the sickest of the sick in case it didn't work. You didn't want to actually make it more likely that they would die. And so maybe they were excluded from these studies that were not controlled or that were not randomized. And so because of that, all that matters were the randomized controlled trials, and lo and behold, the randomized controlled trials have all come back in so far. Some are still ongoing, and none of them has shown any strong benefit. Some of them have even shown a possibility of harm, that taking the drug might make you stay in the hospital even longer than not taking the drug. They've been looked at early use, they've been looked at later in the therapy, so like throughout the whole range of the sickness, the answer is in right now. And because all of these studies have been conducted, if in the future there are larger studies and it shows, well, maybe there's a tiny, tiny, tiny benefit that's really, truly statistically significant, just because it's statistically significant doesn't mean it's going to be clinically significant. And so right now, because these studies all showed no effect, then that means what we can say is that any true impact at all is likely going to be very, very, very small, because these all came back negative. And so that means it's not worth pursuing if it's not a drug. There are other drugs using the same rigorous criteria in randomized controlled trials that have passed that test. So as an instance, we can look at remdesivir or dexamethasone, which have passed and they work. And so this is great news. And we have there's a bunch of other drugs being evaluated. In fact, let me share my screen over here. I wanted to just show the drug tracker. I go to this website occasionally. The New York Times has this drug tracker, and they keep tabs on all the major therapies that are being looked at right now. And there's a lot of other great drugs being looked at. One of the problems is that 1 in 6 of all of the clinical trials that were conducted in the US, apparently on the CDC's website, 1 in 6 of them were for hydroxychloroquine. And so now it's essentially a worthless drug, and we could have been spending our money and our time and resources investigating all these other candidates, and we didn't because of the political pressure for hydroxychloroquine. So I can just go through some of these others. So remdesivir passed, it looks good for now. It's still being used under an emergency use authorization because normally it takes way longer to approve a drug, but it looks much like it's a much more likely candidate based on the clinical trials that have come back. There's some other drugs that are being looked at as well, a bunch of other promising candidates. These two, lopinavir, were previously HIV drugs, and they were tested. And at first we thought that they would be good drugs. We thought they'd be great candidates based on some early test tube analysis looking at viral replication. But the problem is when then you test these candidates in actual human living, breathing people, then they don't necessarily fail because people are not cells. It's like a Rube Goldberg device, I always say, where there's so many different systems interacting with each other. Just because something works in a petri dish or a mouse or a dog or other species does not mean it's going to work in humans. So we can go through some of these. Another one that sometimes we talk about is convalescent plasma. One of the interesting things about convalescent plasma, and so plasma, again, what they do is among people who have recovered from COVID-19, they presumably have antibodies and T cells and all these great potential mechanisms to fight SARS-CoV-2. And so if you take some of their blood, you remove just the plasma, so just the portion of the blood with the antibodies and the T cells and all this kind of stuff, then inject it into someone who's sick, then this should be able to have the full benefit of recovery from the person who recovered. The problem is that the convalescent plasma is not coming back as a miracle drug either, as a miracle cure. Some studies have shown a good, strong benefit. Other studies have been weaker and it's not really clear. It's not really clear on the best timing of when to do it, if it's early in the disease, late in the disease. So this is something that's still being studied. Again, it's interesting because in addition to the antibodies, you'd expect that any T cells, that's come up a lot in the conversation, that there would be T cells that are in here as well that could be beneficial. I'm placing my bets on the monoclonal antibodies. And so for this, what's different about these and why it's not a vaccine is that the monoclonal antibodies, they looked at lots and lots and lots of different antibodies. So when people produce, I've mentioned this earlier, but I'll just say it again. The virus is very complicated. It has lots of little things sticking out. It has the spikes and all these different proteins sticking out on top of its surface. And so when our body creates antibodies, there's not just one antibody for one virus. There's many, many different possible antibodies that you can do depending on where it hits on with the virus. So maybe it hits the top of the spike, and then you'd have one type of antibody that perfectly fits the top of the spike. Then maybe there's the side of the spike, and there's another antibody that forms for the side of the spike. Well, so monoclonal antibodies, what that does is it has looked at lots and lots of different possible antibodies that have been generated out in nature by people. And they've looked at all these different possible antibodies, and they've identified the ones that seem the best candidates for neutralizing the virus. So maybe the very top of the spike, I mean, I don't really know where it hits, but the ones that have demonstrated that they're the best candidates. And then what it does, instead of a vaccine where you stimulate your own body to make antibodies or have a T-cell response or other type of response, instead, they just make massive clones, massive copies of that one specific type of antibody that's been shown to be so effective. And so right now, these monoclonal antibodies are going through the clinical trials. It's still early. I expect to hear some sort of readout in the next couple of months, maybe sooner, but we'll see how that goes. This is going to be expensive. Unlike a vaccine, which we can get for cheaper, the mAbs are much, much more expensive to produce and much more complicated to manufacture, which means that even if we get them, it's not going to be the end of the epidemic. The vaccine, if we got a great vaccine that worked 100% of the time in most people, which is an ideal that we can't achieve, but let's say it was true that we got 100% effective vaccine, then as soon as you just did widespread distribution of the vaccine and got the vast majority of people vaccinated, then the pandemic would be over. And that would be somewhat cheap, and we could do it. The manufacturing's already begun. With the mAbs, it's because it's so much more expensive, it's time consuming, it's much more challenging to manufacture. It's going to be more complicated, and what it's going to mean is that presumably we might be able to use this prophylactically. So among the highest risk people, so the healthcare providers, people who are over a certain age, maybe people with comorbidities, some of them might take it prophylactically, and then for others, if they do get sick at the very first sign of infection, you'd give them a mAb. So this one thing could maybe put it mostly to an end, at least in the wealthy countries that could afford getting many hundreds of thousands, millions of doses of this thing. And so that's what I personally, I mean, I don't have any special affiliation with this. I don't know how the clinical trials are going. I have no visibility into any of this, but I've worked with mAbs in the past in other therapeutic areas, and I just personally, a lot of people, I look at different candidates that they like, and this is just a drug candidate. And I just think it's a cool one that I think is likely to succeed. But even this might not succeed. The clinical trials could come back and they could fail. And I have no special insight into whether they'll succeed or not. Another thing we said in previous weeks is that one thing that we do know for certain is that among all drug candidates that go through the trial, so once you identify a drug candidate early on and you begin phase 1 clinical trial, you are only permitted to do a clinical trial on a drug candidate if you are extremely confident that that drug's going to be effective. If it has the best evidence that it worked effectively in animal studies, and you've looked at this and the science makes sense, only then would the ethics be there to enable you to study this drug. And yet, one thing that we know for sure is that 90 to 95% of all of those best drug candidates, 90 to 95% of them fail to come to market because they fail to demonstrate safety or efficacy. 90 to 95% of them. These are the best. These are not drugs that are just random. These are what we think is going to be the next cure for a disease, the next best drug to treat something. 90 to 95% of these things fail. And that's why one of the reasons that the pharmaceutical industry costs so much, that for the drugs cost so much, and there's all these issues with getting a drug to market. But the biggest one is that it fails, and it is what it is. That's just the way the science works, and that's why we know that we can't just start using candidates and people during a pandemic, because we know based on decades and decades of producing drugs that work that 90 to 95% of them end up failing. So that's just the way the world is.
This is not surprising to you that we have all of these treatments and drugs and potential, all these prospects out there, and so many of them are just really not all they're cracked up to be.
Doesn't surprise me, but it's good. The flip side of the coin is that it's great, because if it's just a coin and it's just a matter of getting that 5 to 10% that will succeed, you don't know which they are ahead of time. But if you have a dozen more candidates that are possible drugs being tested, then that means that you have a much higher likelihood of success that one or two of them will make it and demonstrate safety and efficacy. So that means the more drug candidates we have, the better it is. There are some other things that are being investigated.
That's what we love about you, Glenn, that you are always looking at the glass half full. And you're right. The more that are out there and being tested, the more opportunity we have to get to the ones that work. So
there are a couple of things, and this is one of the reasons that people think that the death rates are going down, in addition to dexamethasone and remdesivir that we discussed. Simply turning people in the prone position apparently enables the bellies to open up and people to have more air in their lungs, and that makes a benefit. Ventilators have mixed use. So for some people, you try to give them oxygen until they can't. You don't just put them on ventilators as soon as you would have. It's interesting because most other diseases, it's standard of care to put people on ventilators earlier based on the amount of oxygen in their body. But it's unique with COVID-19 that we needed to change the care for this specific disease for the way ventilators are used. But we figured that out, and so we started using that. We know that this drug, COVID-19, causes a lot of blood clots. It's thrombotic. It causes strokes and heart and cardiovascular heart attacks and all sorts of other thrombotic events around the body, which can cause organ damage and other things. So anticoagulants have been looked at. The problem is that our anticoagulants currently on the market don't seem to be very effective at stopping those types of clots in terms of the way that COVID-19 is working to create them. So there's still some that are being evaluated for that. It's interesting that because of the politicization by the highest level of the executive branch of our federal government, that every drug tracker needs to have a warning that drinking or injecting bleach and disinfectants is pseudoscience and is not an actual treatment, and neither is UV light inside the body, and neither is silver. Some people believe you drink silver and colloidal silver and it's beneficial, and no, it's not. Anyway, so I don't know if there are any other questions on this or if I veered off too far.
No, this is great, and this is a really useful resource. Thank you for sharing this with us. So we're just about out of time. I'm wondering if you could maybe wrap up by sharing, you brought us up to speed what the latest is with treatments. Any news or anything that you feel particularly positive about on the vaccine front?
Well, I don't know about positive. I saw that question a little earlier, and it's a worry that I'm going to express and that I think a lot of us are worried about. And that's with the emergency use authorization that I discussed. So what we talked about earlier, the hydroxychloroquine was given this original emergency use authorization without having a lot of evidence for it, before the evidence was in, and now it's been revoked. This was largely done for political reasons. I mean, you might talk to some people and say, no, it wasn't politics. We did think it could be a good drug at the time. Well, guess what? A lot of people who are looking at the vaccines think that the vaccines will be effective too. And a lot of us now in the epidemiology community are worrying that come October, even if the results of the clinical trials for the vaccine are not done, the FDA might be pressured. Because remember, the head of the FDA is a political appointee. It is totally legally within their rights to just decide on their own. There are expert committees that look at this, but the Trump appointee bypasses all that. They do have legal right to not pay any attention to any committee, what they might say. And the head of the FDA has the complete right to give an emergency use authorization to whatever vaccine they choose. And so in October, that could be really problematic because the evidence won't be there. we won't know if the drug work, if the vaccine actually are safe and effective. But then the problem is that now it's approved for use. The president could say, oh, now we have a vaccine. Look, we were successful. The election's coming up in a month and we have the vaccine. It was even earlier than anyone thought that it was going to be. And now it's here. And the president could say, well, we want everyone to get vaccinated. And then you might have epidemiologists who usually are pro-vaccine when we know that it's safe and effective. It's coming up and saying, no, we don't want people vaccinated everywhere yet because we don't know if it's safe and effective. Can you imagine how crazy this is going to be? A lot of us can totally see the Trump administration doing this. It would be extremely easy for them to do. If the election looks like it wasn't going well, it would be there would be a huge amount of incentive to do it. And it's very worrisome. We've been looking at some polls. I look at these occasionally. This is one from 538, looking at how worried people are for the infection. Around a third, a little more than a third, are very. Around 2/3 together are very or somewhat. And so then a third are really don't appear to be very concerned about the infection. When you break it out by Republican versus Democrat, in terms of Trump's approval, you see that at the height, like 86%, a little between 86 and 87% of people, this was back in April, of Republicans approved Trump's response to the epidemic in the United States. And that has only gone down a little bit. I mean, it's gone down to, so maybe 10 points to 77%, but you still see wide variation. Right now, less than 10% of Democrats think that Trump did a good job. And more importantly, in some way, are these independents who might be more willing to shift their votes. Roughly a third of independents believe that Trump has done a good job. And this can move. If in October a vaccine is released and the newspapers all say a vaccine is released and the doctor says a vaccine is released, then that means even though there's no vaccine ready to use, and even though it might be removed from the market in December or in November, the week after the election, that might be enough to shift things. And that worries me, not because of the election outcome. Trump can win, whoever can win, but in terms of the epidemic itself, this administration has done an appalling job of dealing with this epidemic, and if they manipulate the politics in order to get reelected in the middle of an epidemic, then this would be quite concerning for me. Anyway, so this is something that we're watching. There's nothing we can do about it, I don't think. All we can do in the news is say, well, yes, but if it happens. But at the same time, it's totally within the president's right to do this if the president and the head of the FDA, the president's appointee to the FDA, decides that they want to do it.
Wow. Very, very interesting. Definitely a lot to think about.
Yeah.
In addition to tie-dyeing the mask.
That's true. That's the best thing to focus time on right now.
Let's do that, right? So with that, unless you have any other good news to share with us.
I have good news.
Okay.
I heard that you acquired something over the last week in your backyard.
Oh, I did.
And I'm very enthusiastic about that.
My expert brother, our wonderful hot tub, along with the tie-dyed masks, has been providing some nice relief.
Hopefully not tie-dyeing in the hot tub.
Might. Just might. One never knows what will happen. It is the year 2020, Glenn.
Oh my goodness. Well, congratulations on your new acquisition. I hope you have many years of enjoyment from it.
Thank you. Thank you.
Right.
Thank you. And thank you for hosting this session again. We love being together. And as always, can I ask, can we see you same time, same place next Sunday?
Sounds good to me. I'll see everyone next Sunday. Thanks, everyone.
Questions coming. We'll see you next week. Thank you, Glenn.
All right. Thanks. Bye-bye.